So hello, I want to start the discussion on ship hydrostatistics. And so first, I want you guys to do it's a really easy question. Can you see it? So to map which figure fits the hazard, which corresponds to the ship stability hazard. It's just like matching the pictures with the corresponding description. So any ideas? It's pretty intuitive. Yes.
I think strong winds corresponds to the image 4.
Yes, thank you. So, okay, strong. Oh, for some reason. Okay. And another for the other pictures.
For verse 3,
Yes.
reduction in original stability.
Yes. So you think it's like an extra weight added high up to the structure? Okay. What about the other pictures?
Yes.
Hydrodynamic
effect is, I think, the connecting with last figure.
Bad hull shape. Okay. Thank you. And other opinions?
I think
yeah.
The last figure is the forces generated by waves.
Yeah, okay. So you see a large wave in the figure as well. Yeah. And yes. What about the first and second picture?
Yes. I don't know, maybe the first is extra weight added higher up in the structure.
Yeah, there's also it can be kind of similar in a way.
The first one too, excessive offset load.
Yeah, excessive offset load. I guess like first and third photos are quite hard to distinguish in a way. But it's actually, I think it's meant to be a high up, a person who is like standing high up. So actually it corresponds to the second, fourth description. And actually the second description corresponds to the bad hull shape. And yeah, while the last one is symbolizing the forces generated by strong waves. Okay, so let's move on to the second topic, development of a stability curve with corrections. I think we did not actually delve too deep into this in our discussion, but these are some parameters that may affect the stability curve when we are trying to determine how stable a ship is. So these are known as added weight and free surface effect and free communication effect. I think you guys are familiar with added weight and free surface effect. So can you guys like match these three with the descriptions?
The first added weight have connected with change of stability caused by addition of weight of loading over the last one.
Yeah. And free surface effect. I think it was in the presentation, but I don't know.
I think it's change of second one.
Yeah, change of stability caused by the tendency of the liquid to remain level. So because it's talking about the surface remaining level, it's known as the free surface effect. And the free communication effect is a third effect. I just wanted to introduce this to you because it appeared in other textbooks, and it's about how stability changes when a boundary of an off-center compartment is extensively ruptured so that the sea can flow freely in and out as the ship rolls. So based on this, like this was actually like a warm-up session. And I wanted to show you some, this can be a slightly difficult quiz. So this is how you draw the stability curve with corrections. I think you would recognize this first graph from the presentation we just had. So the angle of heel is plotted against the writing arm in effect, where the writing arm is the value of GZ measured in feet. So there are 4 curves actually when a ship destabilizes. Can you guys guess which curve corresponds to which description? So these descriptions are the 4 different types of cases. The situation before flooding event occurs and after flooding occurs, but these 3 are quite different because they all correspond to the same situation, but the first one only considers the added weight. The second one considers both added weight and free surface, and the third one considers all 3 correction factors. So what would be the ship's original stability curve? Yeah, you can just make a guess. It's not very intuitive. So okay, I'll give you a hint. So the first curve is actually before, like the original curve is actually B. And after that, after you apply the corrections, the situation will change. Okay, maybe any opinions?
Maybe for the after flooding is D.
Okay. Any reasons?
Because like when weight is added, the angle of heel needed for it to reach the maximum is like smaller. And also like after adding the free surface and free communication, it should be larger since the GM is also reduced by the free surface and free communication effect.
Okay, that's a nice idea. Does anyone have different deductions? Or maybe I'll just tell you the answer since there are other discussion activities. It could be kind of different, but it's actually BACD. So after the flooding occurs, the original curve goes up, but if you apply the correction factors, it decreases to C. And if you apply all the correction factors, it decreases down to D. Okay, so let's move on to a slightly easier activity. It's called the free surface effect. So if I kind of explain it a little deeper, it's like the tendency of liquids or also small solid aggregates to change the attitude of a craft's cargo hold or liquid tanks in reaction to operator-induced motions. And as we discussed in the previous presentation, it really depends on how much the tank or container is full. So yeah, if the tank or compartment is partially full, as the ship heals, you will have a strong tendency for the liquid to tend to remain level. So how, like the free surface effect is not desired in general applications. So what are the things that we can try to reduce or mitigate the free surface effect? So I wrote down the things we can change. So is it better to have a few number of large compartments or multiple small tanks to mitigate the free surface effect?
I think the multiple small tank is better because the it can be the controller or detail. Yeah.
Yes, thank you for your opinion. And how about compartment infill? This is kind of easy. Or yeah, is it full or almost full or empty to mitigate the free surface effect? So like the previous question, like image gives you a bit of an idea.
Like the compartment is closed, right?
Yeah, it's closed.
So I'd say almost full, because then there's less space for the stuff to move.
Yes. What about an empty case, do you think? It would be good or bad compared with half full case?
Using the whole is it usable?
Useful?
Prevent the free surface effect. I think the whole is needed
Required?
and required.
Yeah. So the reason and just to
Yeah, Babel. I know Babel is a kind of equal. So I think it like gravity versus position to
oh, it's okay. Okay. So it's actually like the free surface effect is like how it sloshes around a lot. So if it's like full or like shallow, it's gonna be like mitigated. But if it's partially full, it actually experiences a lot of like sloshing motion and a tendency to like remain at a level. So I also found this kind of counterintuitive, but it says that if it's almost empty or almost full, it's the best to mitigate the free surface effect. But when it's half full, it's like kind of the free surface effect is maximized. Okay. So baffles are actually structures that you can use to dampen the effects of the free surface effect. So using baffles is it helps reduce the free surface effect. And this is a quiz that makes you think a little more about the effect. Do you think narrow compartments are more or less prone to cause instability?
Do they have the same amount of stuff inside?
Yeah.
Let's say less.
Yes, you're actually correct because wider compartments tend to show a larger amount of instability, and the narrower it becomes less prone to cause instability. Okay. And what about these? The two questions are actually the same. So if it's a compartment far away from the center line of the ship, do you think it will cause like contribute more to the instability itself or less to the instability?
I guess it's more.
Yeah, the extremes.
Yes.
You have a reason?
Because with putting it at the extremes, that will tend to like easily oscillate, and like it will cause more instability.
Okay, thank you for your idea. I'll also show you the answers in the following slides after we do the last activity. This is like the easiest activity, so I think you guys will just have a fun time reading and have no difficulties. So this is from an article I found about ancient bulkheads and watertight compartments that ancient Chinese shipbuilders used to like protect the cargo and improve a lot of properties. So it was mentioned in like lecture slides. So can you guys guess which words can be used to fill in the blanks? Okay. Chinese shipbuilders made sailboats with what and what as early as the 2nd century. It's actually, yeah, another one. Okay, it's actually the topic, the bulkheads and watertight compartments. Okay. Chinese shipbuilders made sailboats with bulkheads and watertight compartments as early as the 2nd century. Okay.
Could you explain what mast and plug mean?
Oh, the mast?
Like the word we were supposed to use like mast and plug, I don't know what it is.
I think plug is just like plug, you know, kind of like plug, and mast is like the part in the ship in the front, you know, in the structure of the ship. That's used for like controlling. Yeah. Okay. So bulkhead watertight compartments improved what and protected something. Okay.
So I think the improve the buoyancy and protect the bulkhead.
It's right. It's improving buoyancy, and actually it's for protecting. I think bulkhead would work, but also the original answer was cargo. So if you improve buoyancy, it will also protect the bulkhead or also the cargo. Okay, thank you. And development of watertight components continued through the Song Dynasty in China. The watertight components were there to ensure that if one part of the ship was something, the ship itself would not something. Okay. So they are in the blank keywords. Yes.
If one part of the ship was leaking, the ship itself would not sink.
Yes, you're correct. If the one part of the ship was leaking, the ship itself would not sink. This is the essential role of a watertight compartment. And some Chinese naval engineers came up with this idea by cutting up bamboo plants. So that's what I found pretty interesting about this article. In a bamboo plant, the something is split into sections at the end of the section. There is a something-like device that lets in something, but does not let it out. Okay, so yeah, this does not have to do a lot with naval architecture, but do you have any opinions?
The stem is split into sections.
Yes.
And at the end of the section, there's a, I believe, plug.
Yes, a plug.
Like device that lets in water but does not let it out.
Yes, you're correct. So the bamboo plant is actually devised in a very scientific way. So by using this as a model, we were able to make a large-scale version that would protect the ship. In addition, the compartments were used as something in which fresh something could be stored for sailors on board. Okay. We don't have a lot of objects left. You can use the words twice.
I think the answer would be the compartments were used as storage tanks.
Yes.
In which fresh water could be stored for sailors.
Yes, it's correct. So it's similar to how the bamboo plants utilized water. They would use the watertight compartments. And lastly, compartments were also used to help control two things, which are components of a ship, so they could all be used at once. So the ones we didn't use.
The bulkhead and mast?
No. I think the sail and the mast. So I think those are the ones we didn't use. So sails and masts are both parts of a ship, as I explained the mast. So they can all be help control using these compartments. Okay. So like these are like the answers for like the questions. And yeah, thank you for your active participation in the discussion.